And recording.
Already recording. She's making this more exciting than no, it is actually quite exciting because we're here together for our third science chat now on a Monday. So welcome to all of you. Actually, people are still joining in, so that's cool to see. And today I just heard we had to pronounce it as Julieta, right?
Hello.
Right.
Yeah, that's right.
And she's gonna explain us a bit about open knowledge. I'm quite excited because I really don't know that much about it. And I'm not gonna say a lot because I'm gonna give the word to Jens, and yeah, up to you actually. So the idea is maybe 20 minutes or half an hour of lecture a bit even, I think you prepared, right? Then some questions from Jens, and then everybody can just dump questions and have a bit of a discussion.
Yeah, cool.
Right.
Basically, what we are gonna do is like Juli is gonna share her screen with us for 10 to 15 minutes. Then I will do some prepared questions, and then we go to the open discussion. Well, like Vera said, Julieta Arancio is here with us. She's a very good friend of a very good friend of mine from Argentina. Julieta is doing her PhD in Science and Technology Studies in Buenos Aires, right? But right now you are in Switzerland.
In Geneva, yeah.
In Geneva, perfect. And you work with open source and open hardware in Latin America, and also you have many projects, and you can maybe tell us about that later on the lecture. And also you have a very beautiful open source website with a bird. Amazing, I love it.
With a what?
With a bird.
Yeah, I drew that bird.
Yeah, it's beautiful. So she also draws very nice.
Oh.
So you will share now your screen with us, right?
Yeah.
Cool. Yeah. Let's go for it.
Okay, let me know if you can see it. Can you see it?
Yeah.
Good. So first of all, thank you for having me here. I'm used to talk more about open hardware, which is like the topic of my thesis, but I'm in general a practitioner and a passionate person about open knowledge. So thank you for having me here. It was nice to put together all the things. So I like to open with that quote because I think it's true. And especially when we talk about science, I'm gonna go from more general to particular. So we end up talking about conservation ecology, for example, and which are the opportunities that open knowledge and open science has for the field and for people who are interested in doing open things. So I like that because it says exactly what I think about it, which is we always think, well, if there is an open knowledge, if there is open science, if there is open data, there is closed data, closed science, closed knowledge, and it's a bit weird to think about closed knowledge. And John Wilkes, I think, sums it up very, very nicely, saying it is not closed, it's broken, it doesn't work. So we will see all the things that I will go through in this small talk. They are all intensified from the emergence of the internet. Like everything became faster and faster and faster with all the sharing. And I think one thing to sum up openness nicely is to say that there is no way we can remain closed in the areas of knowledge, of science, of data, because it just doesn't work anymore. So when we talk about open knowledge, when I was proposed to give this kind of chat, I said, okay, open knowledge is open data and open content, which are the building blocks that are freely, you can freely share them, modify them, use them for anything you want. And then it's not only that, but it's on top of that, the process that are transforming the data into information, into knowledge, because it's not just having the data there as a huge spreadsheet in a website that you have no idea what to use for, but it's also the processes of making sense of that data. And that is usually the part that is lacking everywhere. So this is the open definition. The open definition was a project of the Open Knowledge Foundation around in the early 2000s. And all this world of openness has like a common root in open source software, and earlier in the Free Software Foundation and Richard Stallman and the GNU project. So you will see that the 4 freedoms of software that are free to use, free to modify, to study, to share, to redistribute, are replicated and translated into data, open content, open hardware, open educational resources. It's extrapolated to many, many different fields. So what does it mean that is open to share, to redistribute, to study, to use? Well, you have to be able to access it, and it has to be available. So you have to be able to download it, basically, and it has to be machine readable. So I don't know if any of you have worked with data sets, for example, that are online, but they are like a scan of a PDF, and good luck. What do I do with a table that is scanned? And it's impossible to work with it. Reuse and redistribution in the sense of that there are no paywalls, that there are no problems in the middle that don't allow you to download the data and to use it and make sense of it. For example, that it has proper metadata or proper information about the data set that gives you idea of what is in there. Because another very common example is that, yeah, we have open data, and then you go to the website and you just have a huge spreadsheet and you have no explanation about it. So that's not truly open data. And universal participation is quite important, because a normal kind of misunderstanding with openness is that if something is open, it's not commercial. It's not, you cannot do a commercial use of it. And in fact, the open definition doesn't say that. Universal participation means that you can do whatever you want with the data, even make a business out of it. And another very important part of it is that it should be accessible, for example, in terms of language. Try to put it as open to people are there to be able to use it. So all of these things, the final end goal of all this is that your data is interoperable. Because as I was saying before, the idea is that open knowledge is built upon building blocks of open data that can talk together. And that's in being like the only way that we can make data talk together is if they are interoperable, which is something that currently doesn't happen much. So as I was mentioning before, this is not that comes out of nowhere, but around 2005, 6, the world of open data started like being everywhere, especially in governmental data, like transparency for government's budgets, where it's like not only the budget, but for example, access to environmental data, all the OpenStreetMaps, for example, all the geographical information that is available lately. But there are some like milestones that came before this that I was mentioning before. No, the main one in the late 80s with the free software definition, the open source definition, and then free cultural works and a Creative Commons license. Finally, in 2006, we arrived to this open definition, and people have been working on top of that to make it grow in very different domains. So I wanted to stop here for a minute just to understand why. Why should we go open, or why should knowledge be open? It may sound very like morally correct, or knowledge should be open, and I think so. I think we should build like a commons out of knowledge. Like knowledge should be something that is part of a public good, so everyone can build on top of it and everyone can use it. But there are also like very concrete benefits of having open data that are the arguments that are used usually to convince people quickly that data should be open and knowledge should be open. And it is that if your data, like in a world like our world where data is everywhere, if data is not open, meaning that it's not interoperable, it's not findable, it's very difficult to use, then we cannot use it. And reality is that there is data about everything nowadays. And it's quite silly not to be able to build services, for example, on top of them. It can tell you, can give you, for example, more efficient health systems that will give attention to people in a quicker way, or all this traffic information systems that can prevent traffic jams, or environmental information about the quality of the air you're breathing, or how suddenly, like in some cities, well, it's better not to go running this morning because their quality is horrible. So this kind of services that can be provided using the data that is there, just to happen, need to be open and interoperable, because if not, it's just very difficult for it to happen. Besides the efficiency benefits, there are lots of philosophical motivations to go open. And ones I would say, like, the most important is what I mentioned before of building the knowledge commons, because knowledge should be a public good, as air, as water, things like that. So this is like the philosophy behind the openness movement, building the commons of knowledge as a public good. So some domains of application, because open knowledge is like a huge concept. For example, this map is showing all the websites or resources where we have open data available around the world. There are lots. There's the logo there of OpenStreetMaps. OpenStreetMaps is a community curated geographical system, so you can, just like Google Maps, use OpenStreetMaps, and you can contribute with your own information about your own place. And in some places, it's much more complete than Google Maps, for example. That Create, Imagine, Discover, Smithsonian Open Access is something that happened recently. That is, Smithsonian went open access, and there's a huge catalog online available for everyone to use. The idea is that, and this is backed up by things that happened in the past, when institutions open up their resources, people start working with them and produce incredible things that were not able, like, could not have happened if the resources were not open. But we'll see some examples later. But the idea of public institutions, especially going open, is very powerful, because it's like taxpayer money that is, it should come back. So that's one of the other main arguments of open access and open data. Open trials, for example, is like something that if you think it twice, it should be common sense. But most of medicine trials, for new medicines, like clinical research trials, the information was not open. So it was very difficult for someone in another country to understand what happened in a trial somewhere else. So how are you advancing? You will see that in science and medicine, it's very clear how paywalls and closed data are broken. And finally, the government. Like, government was, again, one of the first domains where open data started growing because of transparency mostly, and where are the funds going. So what is more interesting, at least for me, is how openness is translated into science. And open science is like a huge umbrella, and it goes, I like to see it as if you try to replicate the research process of, okay, you have a question and you do the design of your research, and then you go and collect your information, and you analyze it, you publish it, and then you ask yourself another question. In each step of that process, you can open it. And in science, one of the definitions I like is that to open it, it means that you are engaging with other people that is not you and your lab in each of those processes. And other people means other people in academia, like other researchers in the world, but it also means other people outside academia that are interested in doing science. And in the last 10 years, there are lots of people that are interested in doing science outside academia and are effectively doing. So open science has become super powerful. So in each of these stages, for example, the most well-known is open access, which is if you ever had to search for an article and you don't have an institution, or your university is from a poor country, or you are in a computer where you don't have your credentials for your university, for example, and you want to access a research paper, you will probably have to pay for it. And if you are lucky, it's open access, but if not, it's between like $30 or $40 per research paper. And that means, I don't know, you mean how many references do you need to read to make some work? So open access is the idea that research, peer-reviewed scientific literature shouldn't be behind paywalls, because it just slows down all the innovation and science process of building on top of other people's work. So it just makes no sense. And besides of the efficiency and science per se argument, there is also a justice argument. By putting a paywall, just only the people who can pay it can access to science literature, and it's unfair. So what the result is that we have always the same people producing knowledge, right? Always people in the same institutions, always people in institutions. And so open access wants to give it like some, I say the origin of it was very weird that publicly funded research was paywalled. Like governments found themselves paying up to 4 times for the same paper because they pay for the researcher to be there. They give university money pay for the subscription to the journal. Then they pay for the access to the journal. It's crazy. So that's, I think one of the most important aspects of that is Plan S in Europe, that is being implemented somehow now, or like was launched last year. Where it says, okay, all publicly funded research will have to be open access, which makes sense. So that's the end, right? But if you go to the analysis, like what you publish is your data in general. If you are either social science research or scientist, like Harvard scientist, and your data usually it's not open. Like open access has had a lot of attention, and there are many journals now that are open access. And if you are lucky and your institution pays for you to publish open access, then you can save yourself like $2,000, but you can do it. But the problem is that with data is not that common yet. In some fields, it's common. In ecology, for example, they are doing it more and more. And the idea is that we go back, and not only we publish like the paper, but if someone wants to take a look at my data and analyze it to reproduce it or to do something different with my data, then she or he can do that. And for that, they have to be able to download the data set. And the data set has to be open, and to be open has to fulfill some criteria. So fair data is a standard that came up not so long ago, but is worldwide enhanced now, and is trying to foster scientists and also outside academia. But in science, it's very clear that you have to have proper metadata about your own research data, indicating how it was obtained, how is it organized and structured, how people can use it or reuse it. And then it has to be findable, accessible, and reusable. So we will see some services that are in place to do this. Open source, well, software is part of research. So the idea is that if you don't have a license, you can't analyze your data. It's a bit weird. So there are more and more open source software initiatives to have this research tool chain in different ways. Open educational resources. This is something that is quite important because it's weird, again, that you cannot access education if you cannot pay for it. And there are many initiatives trying to fulfill this goal. And finally, citizen science and open source hardware. I put them there in the side, but we will see later because there is more to say about that. So open access, yeah, this is what I just said. Almost $40 for an article, Plan S. This is Zenodo. Zenodo is a service where you can upload your data and you get like an identifier for your data, which is also nice because you can be cited by your data. Open source software, some examples of open source software that people use every day. QGIS, if you have geographic information to analyze and you need open source software to analyze it. Jupyter Notebooks for data analysis online, again, open source software. Python and R. I always put the same example, but this image of the first image of a black hole that was obtained was obtained with open source software. So it's quite powerful. Open educational resources like Wikibooks, like this portal, OER Commons. This is more and more common everywhere. And citizen science, I like to make always the distinction, because originally there were two definitions of citizen science. One that is the one that became mainstream, and another one that was a bit like left behind. The one that is finally the mainstream now is more related to ecology and to biology, and it kind of puts the citizens or the people outside academia as contributors of data. So what this initiative say is, hey, through digital means and the internet and networks, we can now amplify the power of research, having citizen scientists everywhere. So we can have volunteers for our research projects and have much more powerful studies just by designing proper protocols, proper ways of engaging people. So for example, this very nice drawings there are a screenshot from Foldit. Foldit is a video game that helps people, like it guides people through, it's a game of folding, finding the best configurations or the most configurations that satisfy a series of requirements. And these configurations are configurations of real proteins. So this one is from coronavirus. They are working now on the proteins related to the coronavirus outbreak, but they have found like the biggest success of Foldit was that they found a mechanism for AIDS treatment in a protein that would have taken like 15 years for a normal team, for a normal team in 1 year, something like that. So because they had all the power of people collaborating and looking which is the best configuration of the protein to fold it, those proteins are folded in a certain way, and they did it like 15 years versus 1. So that was like, whoa, this is amazing. And that another kind of example of that is Solar Universe, but with astronomy. So they have people looking at images of galaxies and categorizing them according to what they see and what shapes and some rules that the scientists prepare. And again, they accelerate discovery a lot. And Naturalist is another platform. I think it's mostly related like eBird to observation, like amplifying your power of, for example, making a survey of all the population of bees. That was the Sunflower Project in the US. They wanted to survey all the population of bees in the US. So a researcher designed a protocol for someone to like grow a sunflower, and like take notes at certain times of the day about the bees and where they were, blah, blah, blah. And she surveyed the whole country in no time. So it's super powerful, but it has received some criticism, and that's when I want to move to my last one. That is, it's cool to have lots of people involved in your research. It's also cool to involve them in the stage of designing research, because you can give people like more the role of, okay, what would you like to research on? You know? If you were the scientist, like which are the questions that are of interest to you? And then the flow of the collaboration is more of a collaboration. So there I go to the last part, which is like going really, really back in the research process, which is opening the tools for making science. So I put some pictures there. The one with the big balloon is the one about from Public Lab. This was again in the early 20s. I think it was 2010. There were like two very, sorry, that's my cat. There were two very big disasters, like environmental disasters. Fukushima, I think was 2010 or 2011, I don't remember, and Fukushima in Japan. And this one was the oil spill in the US, in the Gulf of Mexico. It's called Deepwater Horizon. So in these two disasters, what happened was that the government of Japan and the US was not given information of what was going on. So in Fukushima, some people started assembling Geiger counters, do-it-yourself Geiger counters, and mapping. And they started publishing the map. And then the government had to say, oh, yeah, I think your map is better than ours, so we are going to adopt it. Like, point out to there when you need information. So this was a super powerful thing that society kind of organized and started mapping what happened. And the same happened with the oil spill in the Gulf of Mexico. So the government was not giving any information of the spread of the oil spill. And there was like an articulation between scientists and the community living around it. And they did like a very simple do-it-yourself system, like a huge balloon with a camera and then open source software to take the pictures and put them together and then map the oil spill. And again, people had to recognize that, yeah, it is better. So since then, there has been a lot happening, and the open hardware for science has grown a lot, both in terms of like these community initiatives, grassroots initiatives, but also in academia, right? So the one that you see there in the tree, the audio moth, is like super ear that is open source and records sounds in like a range of frequencies, and you can keep it there and you can keep it logging for a day and then go back and analyze the data. And in general, open source hardware is a bit like cheaper than the proprietary alternatives, and also it's open. So if you want to modify the audio mod because, I don't know, you need something different, then you can ask your friend or someone who knows about electronics and you can tweak it and produce something new. So there's a lot of power in opening the designs of tools for science, because people can have them easily, can have them more accessibly, and also can design on top of that their own things. Also repair them when they are broken. And most of all, there is a huge commitment to, well, not everywhere people are able to do science in the same way. If you go to countries where science doesn't have as much resources as in the global north, then you have universities that don't have budgets, and then researchers have to do what they can with the little money they have. And in this context, open science hardware is super powerful. So that's all I wanted to kind of did a very, very big description of everything I wanted to say, but I don't know, maybe we can keep discussing.
Thanks, Julieta. That was a nice, really fast, but really well informed talk about so many stuff. So I imagine each one can be a different talk.
Yeah.
For the sake of time, because we don't have that much time now, I will just ask two little big questions I have prepared. One is like, okay, yeah, it's very interesting, this idea of open knowledge, very useful, but at the same time, isn't the idea behind intellectual property, patents, for example, to defend creators? So if everybody takes your own creation and uses it the way they want, then maybe you won't make a living, right? Like, then what's the argument then? Like,
so even the people who defend the patent system say it's broken, because if you see the things that are patented, it's like it makes no sense. But that's the most that fear is the first thing people express when you go with the openness concept, right? So I go back to what I said in the beginning. Open doesn't mean non-commercial. So you can, in fact, the audio moth is open and it's a commercial product. Hugging Ecology, the tube there it has lots of modules for water quality assessment. It's a commercial product, or it's planning to be a commercial product. So in fact, what is happening is that people are developing new business models based on openness. For example, if you have produced a device that is open, then yeah, you don't have a patent, but it doesn't mean that researchers will want to build it from scratch every time they want to do something. In fact, if I am a researcher, I prefer to buy something that I know it works. So some companies, open hardware companies, what they do is they provide you with a device and they tell you, if you want to fix it yourself, you have the designs here. If you want to tweak it and customize it, you have the designs here. Most of the time, I don't want to. Okay, so people pay for the service of having it assembled, and people pay for the service of having support, because you want to have someone, if you don't want to waste your time on building stuff, you want to have someone that you can pick the phone and say, hey, this is not working, what can I do? So there are different models for openness.
That's nice in the case of open hardware, but for example, in the case of open science, what if I open the data during my investigation while I'm still analyzing it, and then somebody faster than me takes the data, publish an article using the data, and then that person gets all the credit? What happens then, for example?
So the thing is that you don't publish your data just like that. It's not that you just put the data in your website and we forget about it. No, you have to put it under a license. So a very important thing, that there were too many things in the presentation, I don't want to put more, is that every time you release something in the open, you have to do it with an open license. And the open license allows reuse, modification, blah, blah, blah. But for example, most of them, the ones that are used in science and everything, are attribution license. So you have to say, I'm using this open data set that I got from here. And when I said that they got an identifier, is that you have like, not like a URL number, like, you know, like the ISSBN of books, similar, but for data. So
it's like a Creative Commons.
It's right? Like, yeah, exactly. Creative Commons is a kind of license that is used for content, but for data, you can use Creative Commons, but you can use others also.
Just one more question before we open the discussion, and this is a bit more big in the sense it's a political question. So is there a relation between intellectual property and the capitalism model? I think you can also explain that. And is open source in that sense also a political proposal?
Yeah, I think so. If you look at Elsevier, which is like the big enemy, of open access, they have a revenue of 2.5 billion or something like that. No, it's crazy, and they are not agreeing to. They say they don't have funds to fund open access, so that's why you are charged like 2,000 for publishing open access. So yeah, it's a business, and there are political conflicts and there are political interests. So it's very resisted by those who will lose money and power in the middle, and they don't want to adapt their business models. So yeah, what I see many times is that open science comes as a politically washed message, like it's very efficient, it makes better science, it accelerates innovation. Yeah, that's okay. But if we forget like the political claims of open science, which are related to including different people, more people who, again, when you take a look at the map of the proportion of scientific publications in the North and the South, is so asymmetric. If you don't take the political claims into account, then we have a problem. I think, yeah, the message of open science is deeply political, but sometimes we can see it's washed, so it comes in a more digestible way.
Cool, thank you. Hey, now I think if anybody has a question, it's time to make them to Julieta. How did you Espera, can you please turn on your microphone?
Me?
I was wondering, like, maybe people can ask like this, like holding up your hand like this, or maybe just talking.
Yeah, there should be even somewhere a button that you can say hands up, but just start talking. I think we'll
Yeah, we will make it like that. So just ask your question and respect when somebody talks. That's it. So
I can stop sharing if you want to. I think it's better.
who want to go first? Is there any question about this?
Well, I could. I'm quite curious with open knowledge in that direction. Can protection of private, how do you say that? Like private data. So for instance, what's happening in China now with their apps and stuff, can that be protected? Can that go side by side with open knowledge?
Yes. So in fact, the open definition, when you read the extended part, it says that is open data and content that is not personal data. So personal data there's like a definition of personal data again, no? That is not open. And of course, in open science, when you do all the ethics committee, when you are interviewing people, you have to anonymize all the data. And it's a practice that is not interfering with the others. So in my thesis, for example, I interviewed lots of people, and I have to go through the process of anonymizing all that data, asking for the consent from the people, of course, and analyzing all that, and then I release it openly, but protecting personal identity. In the case of, you were mentioning, I think, the surveillance of the COVID and like the tracking of people. I think, that's not open, that's just surveillance. It's plain surveillance, right? But there have been some critics that have pointed out that open science cannot be decontextualized. It has to be a situated practice. So, for example, with indigenous knowledge, it has happened that in the sake of openness, like typical Western institutions and science, goes and appropriate lots of knowledge about plants, about medicinal plants that were belonging to communities. And this is not openness, right? This is completely decontextual practice, and it's wrong. So yeah, there have been criticisms that open science can also be patriarchal. Open science can also be non-respectful of other communities. So there is an inside criticism of trying to develop inclusive practice, of trying to be very careful on the designs of the research that we say it's open. Same with what I was mentioning with the citizen science project. It's not good just using people as data collectors. No? It's good to engage them.
It's actually more like answered by ethics of science in general. Like there's a lot.
Yeah, but it's true that if open science becomes like a washed concept, it's a problem. So yeah, it has been pointed out, and it's an ongoing work, I think.
Yeah, I'm quite curious from all other people. Quite some of you have already published a paper or will be publishing maybe at some point or are thinking about. Do you have knowledge of whether your university is publishing it open, or do you try to get that done, or how is it for you guys?
So I'm from Buenos Aires, right, from Argentina. So in Latin America, open access and open data policies are long-term, they are quite old, from the 1990s. There were initiatives of repositories of scientific papers. And in 2013, and in Argentina and in Mexico, I think I don't remember the year, there were laws that were passed in which they said, like a Plan S, if your research is publicly funded, then you have to make it publicly available. So what happened was that universities started creating repositories. And if whatever you do, my thesis, for example, once I finish it, I will have to put a copy in the public repository of my university. That's the thesis. But for example, with the papers, it's a problem I have, right? And now I just publish, I want to publish something, and I have to look for journals that are open access, because when I take a decision, right? I want them open access, but also I don't want to be charged because my university doesn't pay for me to publish open access, but also usually in my field, the open access ones are not the most like renamed one, are the most famous ones. So it's still a bit problematic. I think it depends a lot on the field.
Yes, you wanted to say something?
I wanted to ask, because Anna, maybe you know, I'm pretty sure because Switzerland, actually you would also know, Julieta, because you're in Switzerland. But I was going to say, I think Switzerland doesn't have to be part of this open access thing. They decided not to be. Is that right? Because they're not in the EU, so they didn't have to. Maybe you and Anna know. I know that we don't have to respect anymore, or we don't have to do the publishing in only high impact journals. That is right, or?
Yeah, I think Switzerland is not very strict with this, or is not pushing this open access stuff so much. For example, the EU is much more into it, right? So all the Horizon 2020 funding and so on are linked with having to publish your papers and your data open access. But I do think that the Swiss universities are supporting open access. At least the ETH has funding to publish open access. For instance, my papers have been published in non-open access journals, but they're published open access, and we just paid a lot of money to have that. Yeah.
Okay.
There is I went to in 2018. There was OpenCon, which is Open Education, Open Access, Open Data conference in Switzerland, and I think the National Science Agency here is called SNSF.
SNF, yeah.
So that was the place for the conference, and like the president of the SNSF came and said, "Hey, we want to implement Plan S here too in Switzerland. We are planning to do it. We have no idea how to. So we need your input on to help us do it." That was 2018. So I don't know. Then I know there are some initiatives from EPFL also. EPFL has a lot of initiatives in open science, but still I don't know if it's fully implemented.
Okay.
Yeah, I think as a researcher, it's often pretty difficult, that even though maybe a lot of people have this ideal of publishing open access, but then the fees are quite high, and then also very often the impacts of the journals or the readership of the journals that are open access, they're not yet as established. So usually your priority as a PhD student, for instance, is to publish in the journal that is relevant in your field, and those are very often not yet the open access journals.
One thing there that I forgot to mention is that many people, because of that, I also do that, is many people publish preprints. So preprint servers allow you to upload manuscripts before they are peer reviewed, and they give you a DOI. So you can say, hey, I want to submit this. It will probably go through a peer review process to some journal. It may end being not open access, but you can access the manuscript here. And that works in some fields. In fact, in particle physics at CERN, for example, people normally work with preprint servers, and it's expanding more to biology a lot, and to social sciences too with the SOCAR. So that's an alternative, not perfect, but
yeah. Concerning that, we, for example, as students and scientists in the conservation world, like, how can we use open knowledge, open science in our own investigations? Like, what in the conservation world, how you see this fitting, and which examples could you give us?
So in conservation, there are lots of things happening. First of all, you can access lots of open data, and there are very interesting analysis that you can see using open source software, for example, Jupyter notebooks, that show you, like, basically taking this online open data and doing very, very nice analysis. That's one. Another one is with tools. There are like this AudioMoth or Hacking Ecology. There are many, many tools that are open hardware, and there are more going open every day. So you can do that. I think it's mostly about collaboration. So if you, what I know people do is that if you're doing research in an area and you want to engage with a community, then there are open science practices that you can put in place to help you get that research done as collaboratively as possible in a non-extractive way. Yes, I would say publishing open when possible, uploading preprints when possible. There is, I think there is a preprint server for ecology. I don't have it now in mind. And just publishing data as much as you can open, just to foster collaboration with other people. I think that's one of the most important ways.
I think in that sense, maybe Jess could give us an insight, because we can also do open hardware, open source conservation tools, right? Like,
sure. And there are many, like in general, environmental sciences are a super interesting field for open hardware. Because people are interested in mapping what's going on in the environment. And if you just make a quick search in the web, you will see that there are, like, the maker community is posting lots of designs for measuring many, many, many things. And these designs can be adapted and used for science. So there are really many, many resources.
So we all have to become hackers.
Yeah, totally. I recommend it.
Yes, is a hacker and she wants to say something.
No.
How are we in time? I think Jess may be last, or we have two more questions.
Yeah.
Okay.
I just had a very, very specific question in terms of like protocol, just to get it right in my head. So if you're saying, I mean, obviously there's many different ways to go about this, but I was just thinking, because you're experienced, so I might as well just ask you, you're saying, get this identifier for your data and then research which community is the best to upload your data to, or do you have a favorite? Smithsonian Open Access, Open Trials, Zenodo, Public Lab. Do you have a favorite?
So it depends what for. If you want your data set, if you want to upload your data set and get an identifier for it, so it's public and it's in a nice format and everything, Zenodo is a pretty good service. Zenodo is in fact hosted at CERN, or developed by CERN. I never remember which one, but it's a really good service for hosting data sets. And it gives you an identifier for just saying, referring to it somewhere else. If you want to, I can pass some resources later, some links later, of archives for different disciplines, because each discipline has like medical archives, social archives, bio archives. If you want to search for literature, plus Public Library of Open Science is like a reference for, in general, biology and medical scientific articles. But yeah, for sharing data, I think Zenodo is a very good service.
Okay, thank you.
Hey, I'm quite curious, maybe a question for Sandra and Jana, and maybe Anna also. How is it in the Balkans? Do you have the feeling that, like, we kind of want to have more research going on in the Balkans by people from the Balkans, right? Do you feel this might help, or is this happening already? Like, how are your universities in this sense? Do you know?
I don't have a lot of contact with universities in the Balkans at the moment, so I don't feel qualified to answer that question.
But also Yelena, don't forget about Yelena.
Oh, yeah.
I just said like, whew, because I think it's still not really open, and you have troubles to access a lot of things through the University of Montenegro, which should be. So I really don't have like also a lot of contact anymore with the university and with the people there, so that work at university and that are really doing some research. But I knew that when I was a bachelor student, it was also really hard to access some things. So yeah, so we had to pirate, but it's easy to pirate everything. So I guess that was not a problem.
kind of open access also.
Quite open access. You can have everything. Yeah.
Well, yeah, and that's another discussion, because some people say that's illegal and everything, but people should do like a statue to the girl behind Sci-Hub, right? Because
Has
I don't know.
anyone written a paper without Sci-Hub?
Huh?
Hands up. Who has written a paper without Sci-Hub, without using it? Hands up. I can't.
This is being recorded.
I don't do research.
I forgot that this is recorded.
Well, what? I didn't understand, but I love Science Hub. Are we recording this? I love Science Hub. Should I repeat that I love Science Hub?
Sorry, we didn't get you.
I was telling.
Is there any burning question, remark, addition?
Yeah, before the Gestapo get us. Me and all.
Otherwise, I think thanks a lot, Julieta.
Oh, thank you for the invitation.
Thank you, Julieta. Thank you all for being here in the space with us.
In the space.
See you next Monday.
Next week is with, oh, there's some people, oh, they clap. Wow, I've not seen that.
Somebody's clapping. Wow. Impressive.
Next week is actually a bit more in the Balkans. So it's Mate from Croatia, who's done a lot of research on the Sava and is now doing research on the Phoenix. I'm not sure, I'm not a biologist, but an important endemic fish species. Jana, you're laughing, maybe you know the one I'm talking about. Either way, he's going to talk a bit about how he's doing science on the Sava, which was actually the place we were going to go to, but we're not going to go to it due to the coronavirus. So yeah, thanks a lot for this insight. I learned quite a bit, actually. Even thinking about using it already before you have the data, that's cool, I think. Huh.
Yeah, it's going to be really, I think, important to communicate even this with when we get in touch with universities in Balkans. So it's going to be important to mention to deans and professors and whoever we get in touch with. Thank you, Julieta.
Thank you, Julieta.
If you need anything else, just send an email.
Thank you.
Bye.
Okay.
Bye everyone.
Thank you.
Bye bye.